This is this is lesson 4.1, using graphs to relate two quantities. Your objective is to represent mathematical relationships using graphs. You can use graphs to visually represent the relationship between two variable quantities as they both change. The graph below shows the trioxygen concentration of a gas sensor as the altitude increases. The variables are trioxygen concentration and altitude. The trioxygen concentration varies as the altitude increases. Tables and graphs can both show relationships between variables. Data from a table are often displayed using a graph to visually represent the relationship. For example, a band allowed fans to download its new video from its website. The table shows the total number of downloads after 1, 2, 3, and 4 days. Create a graph that could represent the data shown in the table. Here's the table. Our columns are labeled as the number of days and then the total number of downloads. We will use these to label our axes on our graph. Since the number of downloads depends on the number of days, that will be our vertical axis. Since the number of days does not matter or depend on the number of downloads, we will put that on the horizontal axis. Since days range from 1 through 4, we can use those numbers to label our axis. The downloads range from 346 to 10,426, so we can use intervals of 1,000. Once you've labeled your axes, you can start plotting your points. So on day 1, we have 346 downloads. Day 2, we have just a little bit above 1,000. Day 3 is about halfway between 3,000 and 4,000. And day 4, we've passed 10,000. In problem 2, the number of downloads, which is on the vertical axis of the graph, depends on the day, which is on the horizontal axis. When one quantity depends on another, show the independent quantity on the horizontal axis and the dependent quantity on the vertical axis. Problem 3. A model rocket rises quickly and then slows to a stop as its fuel burns out. It begins to fall quickly until the parachute opens, after which it falls slowly back to Earth. What sketch of a graph could represent the height of the rocket during its flight? Label each section. So we don't have a table for our information here, but we can sketch a graph of what's happening. So in the beginning, the model rocket starts on the ground at the origin 0, 0. As time goes on, it rises quickly and then it slows to a stop. At this point, the fuel burns out, so it's stopping at this height. Then it starts to quickly fall back to Earth. So notice how the incline and the decline are pretty steep here. Once the parachute opens, it's going to fall slowly. So it's not going to fall as sharply. So it'll take a lot longer for it to reach the ground. So the beginning part of this graph represents that the rocket is gaining a lot of height in the beginning because it's rising quickly. So that's the incline. Here at this top part of the graph, we notice that it stops. That's when the fuel burns out. So now it starts to fall down. So the height is dropping significantly. Notice that the decline is also very steep. This is the point where the parachute opens. And so now the rocket is slowing down. So it's going to fall a lot. It's going to take a lot longer for it to come down. So the height decreases, but at a slower rate. See you tomorrow.